Hey, it's Mrs. Golding. We are on page 598 in your textbook, section 8.3. And again, I'm just doing the guided practice for these sections. Unless you need something else, feel free to email me a problem number and I'm happy to make a video for you. I was looking at this question and I had to read it several times. Some math questions are just silly, like the guy that goes to the market and buys 53 watermelon and I'm like, why would he do that, right? I don't know. Why would he buy that many? This question's kind of like that for me because it says it shows the number of inches of rainfall X, which is right down here. Boom. Well, I didn't want that. I wanted this. Boom. That is equivalent to inches of snow. So here's the deal. What it's saying here is if you look along the x-axis, 1 inch of rain is equal to 10 inches of snow. Okay, now think about that. So the idea behind it is snow is fluffy, doesn't take up as much space, right? It's not as dense. The molecules are not as dense in that. Well, I guess per flake, they're more dense because they're frozen, but it's fluffy, so it crystallizes. I don't know. Anyway, but if that were true, every time we got an inch of rain, it would be like a foot of snow, like if it were truly equal. I just think that sounds silly to me. So anyway, Mrs. Golding, quit thinking so hard about these, right? Just do the math. Okay, I will. So make a function table for the input output values. Okay, your x values are your input. Okay, so those are down here. So for every 1, like I said, 1 boom inch of rain, we get 10 inches of snow. Come on now, write for me. This is silly. Let's see if I can get it to write. That's a 10. Okay. For 2 inches of rain, it would be equal to, you guessed it, 20 inches of snow. 3 is 30. 3 inches of rain equals 30 inches of snow. Can you imagine 30 inches of snow? That'd be a lot, like 3 feet of snow. And then, I'm sorry, this is not like me very well. So 4 inches of rain, come on and draw the 4, is 40 inches of snow. It's not copying. You know what? Maybe my fingers are too cold because it's really cold outside. I had to cover up all my plants. Let me see if I can warm them up. I don't even know if that's a thing. Some of you that do technology are like, that's not even a thing. Okay, so let's write an equation about this. So we're going to write it like this. Y, no, it's not a thing because it's worse. Y is equal to something that we're doing to the x, right? So what are we doing to the x every time? We're multiplying it by 10, right? So y is equal to 10x. Okay, so that's the equation. All right, so let's look at the next problem, number 4. This one says, how are ordered pairs of a function used to create the graph of the function? So here is just one of the equations we used in a previous problem. And here's the table of values that goes with it. Remember, the table of values is just the ordered pairs written in a table. Okay, so all you do when you're going to graph these is just remember that when you're graphing on a coordinate plane, that you have your x value come first and then your y value. So x value and then your y value. So all that to answer this question, you change your use your ordered pairs to graph your points, and then you can connect the line if it's asking you to do so. Okay, hopefully that helped you out, and we'll see you soon.